You saw my colleagues talk on yesterday morning probably, and they talked about some of sort of the designy issues we had, but another issue we've had is we've scaled up and gotten big is performance. Particularly just having a big sort of like table-driven app with like tons and tons of bindings, it gets really heavy. Yeah, I work at Google. I work on DoubleClick. Sometimes I contribute to Angular, especially in performance-related pull requests. Just sort of going to set up, sort of talk about the problems, and then talk about what to do about them, and talk about what Angular is, how Angular is going to improve to address a lot of them without having to do anything. All right, so what makes an Angular app slow? Well, number one, it's a web app. It's JavaScript. I'm not going to go too much into that stuff because there's tons of great talks on that already. So then, really, what's Angular all about? Well, there's DI and services and directives and magical two-way binding, and the DI and services and that stuff, those are fast. You don't really need to worry about that by itself. But directives, it's possible to write directives poorly and make your app slow. And when you get to the dirty checking that drives the two-way binding, that can really bog down if you have a lot of bindings. And so we're going to discuss some things you can do to minimize that. All right, so what do I mean when I say slow? Really, I want the digest cycle to take less than 25 milliseconds, or little things like typing you can start to feel it. For the click handlers, 100 milliseconds is actually, really it should be less than that. And then, yeah, you take too long and you show a new page and you're just going to leave, so you don't want that either. Also, make stuff faster. Think about, all the, carbon you're saving. Save the earth. All right, so directives have been covered pretty well by other talks, but just is there's compile and link phases, and when your directive is inside of an ng repeat, the part in the compile runs once, and the part in the link runs n times. So just think about that when you're writing your directives. Put anything that can be shared into the compile stage, and actually when you make your factory function, if there's anything that can be shared across every instance, then you can do it there, and it'll happen literally once in your entire app. So, you can create a node to clone, or you can make a single function there instead of having a closure created for every single instance, things like that. The link is to a pull request I did a while ago. I'm not going to show that here, but that'll just sort of show where I actually sped up Angular a bit by making it put ng scope on elements by having it do that at compile rather than linking. Actually made a noticeable difference in our app. So transclusion, again, not going to go in too deep, but it helps by keeping the scope in your directive kind of limited, because if you have a local scope to your directive and you digest it, it will digest all of the descendants of that scope. So if you use transclusion, anything that your user put inside of your directive is not going to be part of that scope, so you won't pay the penalty for that. All right, so digest and apply. So when you do apply, basically what that does is call root scope.digest. So like I just said, that means when you call digest, that scope and all of its descendants are dirty checked. So when you're writing a directive, odds are you're going to have your own local scope. And so if you're doing something internal to that directive that doesn't really affect the outside world, you should use digest rather than apply, because you'll be dirty checking far less of the overall app scope. All right. So watchers are pretty fundamental. It turns out there's a few different ways to watch in Angular, and which one you choose can actually impact the performance of your app pretty much. Also, just as a general rule, the first argument you pass to a watcher will get executed many, many, many times, so you have to make sure it's fast. All right, so when you call watch, by default, whatever it's watching is just going to compare it by reference, which is mighty quick. But then if you pass true as the third argument, then it will do a deep comparison. And what that ends up meaning is that it recurses through your object, certain arrays, and whatever you pass in there, which can take a while by itself. And then in order to keep track of what the current value is, what the next value might be, it makes a deep copy of that as well, which is another pass through it, and it's slow. So avoid it when you can. So in 1.2, they added a nifty thing called watch collection, which is now used in NG-repeat. And basically, it sort of does like a one-level deep traversal for comparing things. And it handles an awful lot of the use cases where you might have had to use a deep watch before. So definitely check it out. All right. So this is a little more esoteric, but you've probably seen like scope.eval. It just sort of evaluates an Angular expression against the scope. Under the hood, it uses a service called parse. And basically, parse does the part of like reading the string, like tokenizing it, figuring out what it is. So if you call eval all the time, what you're really doing is like you're redoing that tokenization over and over and over again. So really, it's better, if possible, to call parse once, and it returns a function, and then you call that with the scope you want it to be evaluated against, and that can save you some time. And then with respect to interpolate, if you give interpolate a string, you can think of like everything that appears in the double curlies, like it $parses that little bit, and then sort of string concatenates the whole thing together. So if you've got like a really simple thing and you're literally just doing like curly curly, like a single value, calling parse on that is like twice as fast as calling $interpolate on it. All right, so just putting together some of the things I've brought up so far. So like here we start with a function. So like we're using eval. It only has a link function. So if this thing ends up in an NG-repeat, that link is going to get called n times. So we're evaling, and then we're watching something else. So the change is to add a compile step, and then we recognize that in fact like we can use parse to read those expressions once, and then in the link function, then we call the parse output, and you can even watch it, because in fact, watching it saves time too. And then of course we switched from a deep watch to a watch collection. All right. So diving a little deeper, we had an instance in our app where we have this little directive we can put on checkboxes that will make it act like sort of a select all checkbox where you check it. It like checks a whole region. If like you uncheck one of those, it goes into the partial state. It's pretty nice, but it ended up having to watch like this large like swath of like repeated items that represented the data bound to those checkboxes. And when profiling, I actually found out that like the comparison on that was actually pretty expensive. So what I did was I went into the watcher function, and kind of similar to here, I used just a map to pull out only the part that I was interested in, and then watched that. And in spite of the added cost of like the call to map, it actually turned out a lot faster. So might be relevant. On the other hand, like you have to avoid. This kind of goes against that, but like you want to avoid transformations in your watcher function if you can, because they're expensive. In this case, it worked out, but it doesn't always. So for instance, in the SCE service, which I forget the acronym, I forget what it stands for, but anyway, it's the thing that kind of like keeps like protects against XSS in Angular. In ng-bind HTML, it was like basically what this service does is it goes through and like makes sure that there's no like dangerous stuff inside that HTML before putting it into the DOM. And originally, in the original implementation of that, it was actually like doing this checking on every dirty check because it was in that first function in the watcher. So it turned out to be a lot smarter to watch the raw HTML, and then when that changed, then do the transformation once, and then do that, and then proceed. So that saved a bunch of time. All right, so in relatively recent, I don't know if it was 1.2, but anyway, at some point they added track by index to NG-repeat, or well, they added track by. And what that means is that like by default, it would sort of associate each element in your array of items being repeated over. It would associate each of those items referentially with a DOM node. Track by lets you say like, oh, actually I want to track by like, maybe each of my items has like an ID, so I want to have it actually associate with that ID rather than associate with sort of a reference to the object. But then also, like every iteration of an NG-repeat has a special $index variable added to its scope. So you can in fact track by that. And what that ends up meaning is that normally if your array changes, like let's say you're paging through a table or something like that, you swap in a new array where the old one existed. Well, the first time it did all the hard work of creating like each of those DOM nodes for each of those iterations. And then when you put in this new array, it's got entirely new objects. The references are different. It's going to dutifully destroy all of that DOM it created and then recreate it again for your new array. So if you use track by index, the index of row 0 doesn't change, the index of row 1 doesn't change, et cetera. So it doesn't end up wasting time throwing away and rebuilding all of this DOM. So you can save a lot of time that way. All right, so another recent addition was NG-If. So NG-Show just uses CSS. NG-Show and NG-Hide, they use CSS to hide and show elements, which is fine most of the time. But if you use NG-If and it never ends up showing the contents of that, then the advantage there is that it never actually linked to that content. It never did any dirty checking against any of the bindings that were in there. So if you've got like parts of your app that might never even be visible, you can defer or even like never pay the cost in a given session for that code. And NG-Switch is the same way as NG-If in this respect. Just FYI. All right, so another thing that was added in 1.2 was $postDigest. It's private, like you're not supposed to use it, so consider this kind of a last resort. But what it does is if you call it within a given digest cycle, what will happen is it will register a callback that will be fired after all of the dirty checking is complete. And kind of going to like how we normally do things in Angular right now, like let's say I'm implementing ng class. I say watch the class name, the class expression. When it changes, add or remove it to the class attribute as appropriate. The problem with that is that all we're doing is updating the DOM. We're never going to update the scope as a part of this. So there's really no reason that I should do that, and then the next when you digest, there's multiple rounds of dirty checking until the scope stabilizes. So it's going to run that dirty check multiple times, possibly update the DOM multiple times, really when it only needed to just wait till the end and do it once. So if you have if you're writing some directive that's getting called a jillion times, you can save a little time using this, but I'll more about this later. So, all right. So what if we could just cut down and not dirty check at all? So, yeah, custom directives to the rescue. Right, to the rescue. We've heard a lot of people talk about bind once. Apparently, it's promised for 1.3, so that's really good. But what if we have something that just wants to bind sometimes, but not all the time? Going back to my pagination example, let's say we download a page of data. Really, most of that's not going to ever change during our session, but then we still want those bindings to update when we switch to the next page. So I whipped up a little toy app here. We've got, actually in Google we have a whole suite of directives that do this, and I wanted to open source them, but we didn't have time, so I made a little toy version here. All right, so just first off to demonstrate a bind once, so here I'm typing there. The regular binding is updating, but the bind once isn't. But then so to get to that sort of in-between example, here I've got this this fast bind on notify directive, and I'll show you the source code for that in a minute. So here we've got the yumminess scope object member bound with this on notify thing. We have yumminess bound with bind once, and we have yumminess bound with ng bind. So let's say if I go to the page 2, we'll notice that everything but the bind once updated properly. Go back to page 0, it does that. And then just to sort of show the difference, here I can edit the yumminess of chocolate chips. And we'll see here that the ng bind is updating right away as you'd expect, but the fast bind on notify is not. Also want to turn your attention to at the bottom, I have a little counter for how many dirty checks have been happened per instance of each of these bindings. And every time I do this, ng bind goes up by 2. The other guys aren't budging. So imagine I have some user who's very schizophrenic about cookies, they're making all these things happen, and really they don't need to. So just to quickly bind once. Really couldn't be simpler. As discussed before, I have a compile that is used just to get the parse out of the way once, and then it just sets the text once, and that's it. Pretty easy. So then, like the bind on notify, that's a little more interesting. So here's the notifier, and actually, if you look at the source for my demo page, here I put this guy on the T body, and then I've got an NG repeat on the table row. So basically, what happens is the notifier watches this value, and then issues a notification, and then the bind on notify guys listen to that. They don't do a normal watch. They just wait for this to happen. They just wait to receive that notification, and then they will update their binding when they get it. So that means I can pay the cost of one watcher and do many bindings. So jumping back. All right, so here's the notifier. It's, again, pretty straightforward. It's got a bunch of, I added a few extra features here that I'm not really demoing, but the gist of it is you tell it which kind of watch you want to use, shallow, deep, or a collection. It does shallow by default. And then it watches the expression you give it, and then if you look up here, it just broadcasts when it changes. And you can it just uses the name, its own little constant name right here by default, but you can specify that. And then we go to the bind on notify directive. It's just going to use $on to listen. It's going to evaluate it, see if it's changed since last time, update it if it has, and then just keep track of it. So this is for bind, but I mean it's pretty easy to see how you could extend this to like replace ng class, ng disabled, ng href, whatever, and hopefully we can get like a proper library out there to take care of this for everybody. Or actually, maybe if I have enough time, I can like implement it for 1.3, but no promises. All right, so that's all well and good, but how do you know if your app has got problems? So there's tools that you can use. So sort of walk you through these. All right, so Batarang is a Chrome extension that sort of adds a little guy onto the Chrome DevTools, and you just turn it on, and it'll just start watching your digest cycles and like giving you like little clues about, or like basically telling you which expressions are taking up the most time. It's quite informative. Really good place to start. The profiler is also great. It of course like gives you sort of this broad view, and it doesn't just like look at Angular expressions, but kind of just like lets you dive down. And I prefer using it with like a default to percentage. I prefer just showing actual time and using the top-down approach rather than the bottom-up. I feel like I generally get better results that way. Also, like you don't want to do this in minification mode. Like if you have a minified versus non-minified version, like use the non-minified because otherwise this will be like totally illegible. All right, so like basically you can use the profiler step to kind of identify at a function level like where your problems are. But then like suppose you want to dive in a little further, get a particular idea. Well, most of the new browsers offer a performance, like window.performance, so you can call performance.now to get a high resolution, I think like down to 4 decimal places of a millisecond, very high resolution time. And the nice thing is that you can just like keep you can like make a global variable. I just always call it t, and just keep adding to it for every time, and that way it can actually track like the total time consumed by a block of code. Whereas like if you were just using console.time and console.timeend, they give you like a one-time count, but I really find the sum is a lot more interesting. And then of course if you also do a C, like a C where I'm counting each time this happens, then I can do T over C there to get the average time per execution. All right, so there's other things you can do with this. Like so let's as I alluded to earlier, like deep watches can be expensive because of all the like deep comparison and copying going on. So like let's say you wanted to actually track like the cost of copy in your app, so that you can just like pop open your instance of your copy of AngularJS, find the copy function, and then insert this code into there. The stuff about recurse there is to make sure like copy is recursive, so your counters are going to get all messed up if you don't like check that you're only measuring like the outermost call, not like the inner recursions, or else it's going to be inaccurate. Basically, like this is how I diagnosed that problem with our select all checkbox. So this can be pretty informative, and it'll just like as your thing starts up, it'll print out like what your most expensive to copy things are, and it's sort of up to you to like you kind of have to work backwards because it can tell you what the data is, and then you're gonna have to like figure out like, okay, what caused that data to be copied. So you still have to do a bit of sleuthing, but it can be pretty informative. All right, so Angular has been getting faster. I can claim partial credit for this, but recent releases have had a lot of nifty optimizations. For instance, we've managed to reduce the number of dirty checks in any given digest cycle because what digest does is it's sort of like it goes through, does all the watchers. If any of them came back dirty, it does the loop again and just again and again and again. So if you can imagine the dirty watchers as like a list, like top to bottom, let's say it goes through, this guy's dirty. Previously, so it would go finish up and then go all the way through again. Really, that means that like this part down here was redundant, so we added short circuiting, so it goes through, finds the dirty guy, continues, and then goes only down that far. So we've cut out on average like half of a digest loop from every digest that in your app. There's lots more stuff to do like that. So what's coming? Something I've been working on is coalescing asynchronous calls to apply. So like what that means is like say you do $HTTP or $resource. Whenever that data comes back, it the promise fires and an apply happens. So your entire app is dirty checked. But like there could be a bunch of like requests in action in flight at once. And in our app, we have like almost 40 of them at startup. And what I found is that if like I put like a little 10-second set timeout at then, and then like call apply after that, and just coalesce them all together, I can like almost half the number of calls to apply when my app starts up. So I think that would benefit a lot of people. Hoping to get that in for 1.3. So then yesterday in the Q&A, it was alluded that bind once was going to make it into 1.3. So that's very good news. So further on. So postDigest watch. So going back to my discussion about $postDigest, I think it would be a lot better if we could have like an actual watcher that was used only for things that update the DOM and don't update the scope. An actual like nice to use public way to do that, and then of course also update all of the built-in Angular directives to use it as well. I think that would be nice. So watcher deduplication. Not actually sure if that's a good idea yet, but what that means is that, like, say on a given scope, you have like 3 different bindings to the exact same expression. Currently, all 3 of those are dirty checked every cycle. Really, like, it would be nicer if we dirty checked it once, fired all 3 of the watchers if need be. Apply isolation. So we've actually, in DoubleClick, we actually have like a sort of hackneyed way of doing this. And what I mean by this is that, like, suppose you have a widget that opens up a dialog. Like in our app, like the way when we do that, really that dialog is a totally different controller, totally different view. It's really almost a separate app. But just because of the way Angular works, any events that happened in that would trigger digest cycles, like a full page applies that would affect everything, like even the stuff behind the dialog that the user can't even touch. So we sort of hacked this thing together that kind of monkey patches apply and like lets you like isolate these regions. And like rather than recommending that you all set out and monkey patch apply, I think it would be better to like actually get a feature like this into Angular. I mean, there's tons of other stuff. So definitely file tickets if you have ideas, or come talk to me after the talk. So thanks. I guess I'm way early.